हेलो दोस्तों, मैं नीलिट एग्ज़ाम फॉर साइंटिस्ट ए बी के पार्ट 3B लेकर के फिर से हाजिर हूँ. आई एम बैक विद पार्ट 3B of the 2017 paper. My name is Vipin Pandey. As we have already seen this all things in my video series 3A, and this is the classifications of questions, and you got to know that this particular part जो अभी आ रहा है from 91 to 120 will be more or less comprising of operating system, software engineering, algorithm. Okay, so these are all healthy parts where a lot of number of questions have been asked. So we will be discussing it today. So not wasting much of the time, straight away we should go to the paper itself. Okay, so 91. This is at a room temperature of 300 K. You have to calculate the thermal noise generated by two resistors at 10 kilo ohm and 20 kilo ohm when the bandwidth is 10 kilohertz. This is easy question of okay. So the formula for it is 4K TBR. K is a constant, is temperature in Kelvin, B is bandwidth and R is resistor. तो आप देख सकते हो कि अंडर रूट का अंडर रूट आर इज़ द वन विच इज़ वेरिंग इन बोथ केसेस. एक में 10 किलो ओम है, नेक्स्ट वन इज़ 20 किलो ओम. सो 10 and under root 10 and under root 20 अगर if we simply calculate, so it comes 3.162 and 4.472. तो अराउंड 1.5% का डिफरेंस है दोनों में. ठीक है. सो इफ़ यू गो टू द क्वेश्चन इटसेल्फ and we see the options, so we see that this one 1.2868 and 1.819, there is a difference of 1.5%, so that's the option. Okay, so option is a CPU generates 32-bit virtual address. Okay, the page size is 4 KB. The processor has a translation look aside buffer TLB which can hold a total of 128 page table entries and is a 4-way set associative. So we have to find the TLB tag. ठीक है. सो टोटल CPU size of virtual address is 32 bit. Okay, so this is the total size. You can understand more clearly here. This is the total size of tag, 32 bits. Page size is given as 4 KB. So 4 KB means 12 bits, and this 12 bits, if you minus from 32 bit, it becomes 20 bit. So 20 bit becomes stacked. But one more thing is given that in TLB, which is being arranged in a 4-way set associative, and 128 page table entries are there. So 128 by 4, that is 32. Okay, so 128 by 4, 32 sets are possible, and for representing 32 sets we need 5 bits. So indexing bit of 20 bit and minus 5 bits is equal to 15 bits. So that 15 bit is the tag size. So exactly we will get C is equal to 15 bits. Okay, next is a computer uses 46-bit virtual address, 32-bit physical address, or 3-level page table organization at T1, T2 and T3. Okay, the PTE is page table entry is 32 bits in size, and the processor used in the computer has a 1 MB 16-way set associative, virtually indexed physically tagged cache. The cache block size is 64 bits. So first of all we have to find out what is the size of page in KB in this computer. Okay, so first of all what all things are given, that 46-bit virtual address is given and 32-bit physical address is given. Okay, so first of all we have what we have to do, we have to find it out to page size, and we assume it is of x bits. And now if it is of x bits, so total number of it can accumulate is 2 to the power x bytes. Okay, means if it is a x bit thing, so the information it can accumulate is 2 to the power x. Number of entries in that page table is based on 32 bits. Okay, so we will have in terms of bytes 4 bytes. तो टोटल नंबर ऑफ एंट्रीज जो टोटल साइज है उससे डिवाइड कर देंगे, तो 2x by 4 विल बी द टोटल नंबर ऑफ एंट्रीज दैट हैज़ टू बी डन फॉर अ पेज in a page table, and that is of 3 layer T1, T2 and T3. So it will becomes 2x to the power 4 into 2x to the power 4 into 2x to the power 4. So if we simply solve it, it will become 2x into x and x plus x 3x, and this 4 to the power 2 minus 2 to the power minus 2 to the power minus 2, so 2 to the power 3x minus 6, and this total is equal to total of 2 to the power 46 minus x. 46 minus x again, how it is? 2 to the power 46 is total uh, virtual address, and x is the page size. So 2 to the power 46 minus x will be the number of pages, and so that is the number of pages we are having here. So we simply put this equation and solve it. We will get 13 bits. So that page size is 8 KB. Okay, and the answer is, the what is the size of a page in KB in this computer? So it is 13 bit, so that is 8 KB itself. Okay, the next is consider data given in the above question. What is the minimum number of page colors needed to guarantee that no two synonyms map to different sets in the processor cache of this computer? So you are seeing that 93, 94 are correlated questions, like a gate questions, 2 marker question. So we have to go through it and we have to find it out that how many pages are overlapping totally, so that we can have to map it with different colors to recognize it. Okay, so for that we need to go through it, that it is having 1 MB 16-way set associative. Okay, and virtually indexed physical tagged cache is of 64 bytes. See, so 64 bytes है, so total number of blocks how we can make? So our total number of blocks is 1 MB divided by 64 bytes, so we will get 2 to the power 14 blocks. Okay, so number of sets also we have to simply make out of this, and number of sets, how many it is? It is written that 16-way set associative. So for that 16-way set associative means 2 to the power 4. So number of sets of total 2 to the power 14 by 2 to the power 4, that is 10 sets. So now again 10 sets is for sets, and total size is 46, and 6 bit is the virtually physical tagged cache size is in blocks. So 6 bit, 10 bit and 30 bit, total 46 bit. Now you are seeing that 13 bit is the page size as we have calculated in the earlier question. So 13 bit hai, and now here total is 16 bit, which is against this tag. So what now, what all 3 bits we are saying which is there, which is overlapping and going to come again. So this 3 bit is what we need as 8 colors for identifying different pages. Next is, a disk has 200 tracks, number 0 through 199 at a given time. It was servicing at the request from track 120, and then the previous request service was track 90. So the pending requests are in this fashion. We have to find it out what will be the traversal path and where the direction has changing in shortest seek time first and FCFS. So this is an easy question. 90 is a 120 means we are going from 90 to 120. Suppose we are going from here 90 to 120. Okay, and then we in shortest seek time first may we have to simply seek 120, which is the nearest in terms of track numbers. So 120 is nearest is 115. So if we are going from 90 to 120, 115 is this side, we have to come back again here. We have to arrange it in increasing order, so that 120 to 115 one direction change, and again from 115 we have to see which is the nearest one. So 110 no direction change, and 110 we have to again see. So 110, so 130, 20 difference, so 110 to 180 it is 30 difference. So we are going from 110 we are going from 110 to 130, so second direction change, and from 130 we are coming back to 80, 70, and also total we are seeing 3 direction changes in shortest seek time first. While similarly we have to go for FCFS. In FCFS we have seen from 90 to 120. Now 120 we have already gone, and we have to go in first come first serve basis. So if we go, so we have to come from 120 to 30, and then we have to go in fashion 30 to 70 increasing, 70 to 115 increasing, 115 to 130 increasing, again decreasing, 110, 110. So second 110, second turn 110 to again we are decreasing 80 and all. So it is going in the same direction. And in 20 for 25 it is going to change, and again 25 to 20. So total 4 direction change we are. It is easy and you will understand. So total 3 and 4. Okay. Next is this question. Consider the following snapshot of a system running n processor. Process I is holding xi instance of a resource R, where R is having 1 to n resources are there. Currently all instances of R are occupied. Okay, सारे resources occupied भी हैं. For all I process, I has placed a request for additional yi instances while holding the xi instances it already has. So there are exactly two processes P and Q such that yp and yq is equal to 0. Which one of the following can serve as a necessary condition to guarantee that the system is not approaching a deadlock? Approaching a deadlock means that all the resources have been vanquished or completely used, and you are demanding a new request which other process is also demanding, and because of which there is a fight and the system goes into a deadlock. So what is happening here is that xp plus xq, they need at least some amount of yi which can make them carry which them allow them to not to approaching a deadlock. Okay. And same way that thing is that resources should also be not the same, it should be different. So first one is minimum of xp and xq is less than of max xy. Okay. So हम that is not a case that you xp and xq का जो minimum requirement है it should be greater than max y and xp plus xq की जो requirement है that should be greater than equal to minimum yi. So that's the case. If we have to be serviced their request is to service by yi, it should be obviously that their sum should be greater than equal to minimum yi. So that's the thing which is going to serve your purpose, and here there is no mentioning of yi and yi, so that's not the answer. So answer is B. Okay. Next is a system has n resources. This C operating system. A system has n resources r0 to rn minus 1 k processes p0 pk minus 1. The implementation of the resources request logic of each processes pi is as follows. See, if I percent 2 is equal to 0 means modular 2 means p0 p2 p4 all will be true here. So if I is less than n मतलब number of resources जो हैं अगर I pi उसका जो number that is less than n, so request ri, so ri resource will be requested to that. And if I plus 2 is less than n, so request ri plus 2 means p0 will request r0, p2 will request r2 in that fashion. Or else if it is not true, then p1 means I is less than n, request rn minus I. So suppose there are 20, so p1 is there, for that it will be requesting r19, and for p3 it will be requesting r17. So you are seeing that from front end it is going in even fashion, from the back it is coming in odd fashion. Now what you have to see from here, that you have to find following situation is a deadlock possible. Now you see n is equal to 14, k is equal to 26, both are even. N is equal to 20, k is equal to 10, both are even. And n is equal to 21, k is equal to 12, even odd. N is equal to 41 and k is equal to 19, so odd. See, the most important thing is both are even, so these two are of same kind of thing, only the number of resources and processes are more, so that will not be answered. Now n is equal to 21, k is equal to 12, and n is equal to 41, k is equal to 19. When one is odd and one is even, then there is a chance of that someone will overlap here. And when both are of different type, no overlapping is happening here, because it is going in 0 2 4 6 fashion, and it is coming in 9 7 6. So this is the only n is equal to 21, k is equal to 12, where